In this video, we'll learn more about trigonometry. As you have studied in your previous classes, trigonometric ratios for acute angles as the ratio of sides of a right-angled triangle. We'll be extending our study here in a one-unit circle and of any angle in terms of radian measure and study them as trigonometric functions. So here I have this green ray in this unit circle, which is on the initial position and coinciding with the final position, making 0 radians. This is my origin O, which is the center of the circle, and it's the intersecting point of the axes called as origin. And this is the ray we are talking about, making 0 radians as it keep moving on to some x radians, y radians, z radians, coming here making 90 degrees, that's pi by 2 radians, then completing the half circle making pi radians, then 3 times pi by 2, that is 3 pi by 2 radians, and completing a circle making 2 pi radians. So let's see here and write. Initially it's 0 radians, then completing 2 pi radians. Coming here it's pi by 2 radians. Here at this point it's pi radians, 3 pi by 2 radians, completing a circle, 2 pi radians. Since it's a unit circle, we can have the coordinates of these points written. Here, let's call this point as A. Unit circle will have this length OA as 1 unit radius. So it will be 1, 0. Here x is 0, y would be 1. Here it is minus 1, 0. This point would become 0, minus 1. Now this green ray, let's move it to make some x radian turns in this unit circle. So here it has made x radian turns. Let's call this point P on the circumference with the coordinates A, B. From this point P, let's drop a perpendicular. Let's have this perpendicular from P on x-axis. What we have here. And let's this point be called as Q. So if P is the coordinate A, B, then OQ length is some A units and PQ length, that is the distance moved on y-axis, this one is B units. And OP is 1 unit since it's a unit circle, keeping every time radius in it as 1 unit. Now looking in this triangle POQ, it's a right angle triangle. So I have my cos x equals to OQ over OP. Cos x equals to OQ, which is A units, OP is 1 unit. So from here we got the value of A as cos x. So I get here A as cos x and B will be sin x. So I have the coordinates P in terms of cos and sin as cos x, sin x. If this OP in this unit circle turns, let's say some theta turns, then the coordinates at that point would become cos theta, sin theta. So any general coordinate on this unit circle will be in terms of cos x, sin x, considering the x radian turns in this unit circle. Let's further move into the study of this unit circle. Looking back in the triangle POQ, which is right at Q, so applying Pythagoras theorem, I get OP squared value equals to OQ squared plus PQ squared. Here my OP is 1 squared, which is 1. O cubed becomes A squared plus B squared. But we have taken out A squared to be cos squared x, and B is sine x, so B squared becomes sine squared x. So this becomes the identity which we already know, that sine squared x plus cos squared x gives us 1. This is our identity number 1. From here only we'll derive the other identities. Let's divide both sides by cos square x. Dividing cos square x on both sides. 1 over cos square x gives you sec square x. Cos square over cos square gives you 1. Sine square over cos square gives you 10 square. So 1 plus 10 squared x gives you sec squared x. That's the another identity that we have. Now dividing equation 1 again. Divide equation 1 by sine square x on both sides. We do on both sides so that the change is nullified. 1 over sine square gives you cosec square x. Cos square over sine square gives you cos square x. Sine over sine gives you 1. The another identity is 1 plus cot square x gives us cosec square x, no matter whatever is our x radian terms in this unit circle. Let's study more here. Now coming back to these points A, B, C, D, let's call this point as B, this as C, and this as D. Since we have cos x and sin x as the general coordinate on this circle, let's see the specific values at 0 radians, pi by 2, pi, and 3 pi by 2, 2 pi radians. So my sine 0, this is sine 0, which is y in the coordinate, gives you 0. And cos 0 gives us 1. Similarly, sine pi by 2 is the y of this coordinate, 0, 1, which is 1. And cos pi by 2 gives us the value 0. Further, coming to pi radian terms, here my sine pi gives you 0 and cos pi gives us -1. Coming to 3 pi by 2 radian terms, our sine 3 pi by 2 value gives us -1, whereas cos 3 pi by 2 gives the value 0. Coming back to 2 pi terms here, this is my cos and sine. So getting sine 2 pi, sine 2 pi value is 0, whereas cos 2 pi gives us 1. So we get to know these values of sine and cos at positive x, positive y, negative x, and negative y. That's all in this video. We'll continue about this unit circle in another video. Thank you so much.